Separating funnels are used for liquid-liquid extraction, also known as solvent extraction. They come in different shapes and volumes, but always ensure that you do not fill the separating funnel more than 2/3 full. Also make sure to clamp around the ground glass joint at the top of the separating funnel. Before transferring any liquids into the funnel, always ensure the stop clock is closed. When the tap is vertical, the stop clock is open, and when the tap is horizontal, the stop clock is closed. When pouring liquids, you may wish to use a measuring cylinder or long-stemmed funnel to prevent spillages. When both the solution and the extraction solvent have been added, layers will begin to form. One layer is the aqueous phase and the other layer is the organic phase. Here we added colour to the aqueous and organic layers to show the separation more clearly, but it is more common for both layers to be colourless. The key to the separation of layers in a separating funnel is density. The bottom layer is the more dense solution, but this is not always the aqueous phase. For example, the separating funnel on the right has the orange aqueous phase on the bottom and the yellow organic phase on the top, because here ethyl-alphanoate has been added to our aqueous solution of water. The density of water is 1 gram per centimetre cubed, but ethyl-alphanoate, our organic phase, has a smaller density of 0.9 grams per centimetre cubed, and hence the organic phase forms the top layer. But on the left-hand separating funnel, the orange aqueous phase forms the top layer and the bottom layer is the yellow organic phase. This is because an organic solvent called dichloromethane, DCM, was added to water, and DCM has a density of 1.3 grams per centimetre cubed. Hence DCM is more dense than water, so the bottom layer on the left-hand separating funnel is the organic phase. In order to carry out an efficient extraction, we must ensure that the organic and aqueous layers are thoroughly mixed. We do this by inverting the funnel. To begin with, you should remove the funnel from the clamp or ring, holding it securely with both hands, and then turn the funnel upside down. When upside down, open the tap to release the pressure that may have built up during the mixing. Then using both hands, invert the funnel 2 to 3 times before opening the tap to release the pressure again. To ensure maximum mixing and maximum separation, you should repeat the process of 2 to 3 inversions followed by the opening of the tap another 5 to 10 times. Then securely attach the separating funnel back in the clamp or ring and watch the layers begin to separate. This separation shows that the dye that we added has gone into the organic phase, which is why the bottom aqueous phase has lost its colour. Now it is time to extract the layers. Always start by removing the stopper from the top of the funnel. Open the tap and drain the first layer into a clean conical flask. Make sure you start to close the tap as the bottom layer drains out to slow the rate of flow and to help you correctly close the tap when you can no longer see the separation between the two layers. Put this conical flask to one side and collect the remaining layer into a new clean conical flask. To obtain the most accurate results, it is best to repeat the whole process twice more, by pouring back in the layer you wish to extract more from. In this case, we want to extract the organic orange layer, but this is not always the case. You add new extraction solvent from a measuring cylinder, not from the layer you have just extracted into a conical flask. And it is better to collect the layer that you want, in this case the organic layer, into a new clean conical flask after each separation. By repeating the extraction process, it ensures maximum separation and therefore helps to maximise the yield of your final product. You then are left with a conical flask of a purified solution that contains your final product. However, you often need to still remove some more impurities, so it is common for this to be followed by distillation or recrystallization.